Okay, I had to stop and restart it. All right, welcome to another illustrious week of SQL from the Oracle Academy. Um, and try a couple things different, but you just have to stand by to see what that means. But no panic, no need to panic. Uh, First thing that I like to do is review. There's a pretty good discrepancy in performance on the quiz and assignments for 9, and I can probably guess that everyone's kind of getting a little burnout um, for the most part, so that's not a problem. And bring up your illustrious faces. So as far as the assignment, I'm going to use one of your submissions so we can review, see what's happening. Um, Number one, which events in the DJs on demand database cost more than the event. So this is subqueries, remember, ID equal 100. So it was a select name. I did see some issues with column names. So really pay attention to that. That can really be a problem. Really, that can be really. So where cost is greater than, and then the operators, don't forget about those. Select cost from D events where ID is equal to 100. So, and it was visual wedding. That was the proper answer. Number two, list the DJs on demand events. Same table. D events whose theme code is the same as the code from Tropical. So once again, another subquery. And if you have any, not many people had problems with the subqueries. It's just putting in the correct information. So this one, select, that's a select, name from D events where theme code is equal to, and then basically select the code. And yes, you can use a subquery to query across multiple tables as long as you have the correct information. Didn't have a big problem with that. So those two were pretty straightforward. As a matter of fact, the first three, you all did pretty well. What are the department names of the Oracle departments that have the same location ID as Seattle? Once again, you have something known where you're trying to, you have something unknown where you're trying to pull in something known, and then select department name from departments where location ID is basically the city of Seattle. Administration, executive accounting, and contracting. All right. Write a query to return all those employees who have a salary greater than that of Lawrence and are in the same department as Able. Yes, that's two subqueries in your where clause. Select from employees where salary is greater than, and then that of Lawrence, and then in the same department as Able. And you see it's an and operative. Pretty straightforward. I think most people got that. The one that I had the biggest issues, and I'm showing you the error, number 5, remember the query was return all those employees who have the same job as Raj and were hired after Davies. I think some people forgot that after means greater than. So you see here that this particular individual, the operator here is hire date equal. So you're looking for employees that were hired after Davies, but the only return is Davies. So the correct syntax here should have been greater than, hire date greater than. And the correct answer, where is it? Well, anyway, Davies, obviously that query doesn't make sense, but let's see if I run, just to take the time to run this query for you. Select, and we're just going to do last name, not everyone. From employees. And I'm just going to do the hire date. well, I guess we'll do the whole query, where job ID is equal to, and then the first subquery, select, and I'm using this one as an example, job ID. Once again, columns to match columns from employees, where last name is equal to Raj. And another thing that I noticed, the case is important in this particular database, so be aware of that. Don't forget about that. Don't get lazy on that. And hire date is greater than, and then your subquery, select hire date from employees where last name is equal to dates. All right. So if I haven't made any mistakes and you run that query, oops, I did something wrong. All right, what did I do wrong with that? All right, okay. Everyone gets a chance to read through this query and tell me what's wrong with it. Based on the criteria of that, write a query to return all those employees who have the same job. Oh, aha. Attention to detail. Everyone see that? Yeah, so if that's, and that was just a misspell of Raj's last name, and so was Matos and Vargas were the correct answer. And I just wanted to point that out. Be aware of all these little idiosyncrasies as far as the details of the actual data, including the mistake that I made. That's why the SQL developer is important. Make sure you review your answers. And then 6 and 7 and 8, I don't think I had anyone that had any problems with that. Most of the problems were on number 5. So good job with that. All right. And then the quiz. Let's take a look at the quiz for module 9. Let's see, where's my little quiz? All right, here we go. And yeah, this one, there was just a few issues. So now we're going to go ahead and walk through all of the questions. So question 1, you need to produce a report that contains all employee-related information for those employees who have Brad Carter as a supervisor. However, you're not sure which supervisor belongs to Brad Carter or supervisor ID. So it's something you don't know. And so which query should you use to accomplish this task? Now, is Brad Carter in our database? Possibly not, but that was one thing that I wanted to. So which answer in here is correct? A, B, C, or D? You all can speak up if you like.
C.
C. Someone says C. Do you all agree with that? Yes, no. Carter, actually.
Negative, because it's grabbing an employee ID.
All right.
So we need to pick A.
So select star from employees where supervisor ID. Well, wait a minute. Why is that? well, do we have supervisor? Well, yeah, this is kind of a conceptual. You actually can't run this because we just have manager ID and not supervisor ID. But so you're saying C is incorrect because it's grabbing, well, you have employee ID and supervisor ID technically in this. Maybe this is a problem the way I worded it. Well, this originally came out from Oracle, but we have manager IDs in the current employees database now, but so well, let's substitute this. We just want to reread this problem. Brad Carter is the supervisor, and we want to produce a report that contains all employee-related information from those employees who have Mr. Carter as their supervisor, but we don't know his ID. So basically you would have a subquery that would pull out his well, this question is kind of confusing. So it's like choosing the most appropriate answer. So Brad Carter, you would want to pull out his employee ID because that's the ID that's used if he's a supervisor. I know but in our database, it's actually the manager ID, and I'm going around in circles. I apologize for that. But this one is a little confusing, but C is the correct answer because the supervisor ID, everyone that has Brad Carter as a supervisor will have his employee ID under their supervisor ID column. Does that make sense to everyone? And that's why C is correct. Yeah, it's a little confusing, and yes, you'd have to substitute a few things to run this, and I'll probably do that in the next iteration of the course because I do want you to run these on SQL Developer, and this one is not applicable. So, but the correct answer is C because that's his employee ID, which anyone that he supervises, they have that under the supervisor ID column. All right, let's move on. All right, so if a single row subquery, and this one had a few misses here, if it returns a null. So if you're returning a null from the subquery, what will happen to the outer query? What do you get in the outer query? And we did talk about this. Basically, you won't get an error, you just get no data. So the correct answer is no rows, B. Does everyone remember that? I know I had a few that I forgot that. So basically null just says I have nothing to query on, so hence nothing. All right, 3. Which of the following queries contains the comparison operator? This one was kind of tricky as well. That is used to restrict rows. So they all do. The in, any, and all. You just want to think of it that way. They all restrict rows. So the correct answer here, even if the query is not correct or it doesn't return any data, they still restrict rows, which is kind of maybe I should bold that. I apologize for that. But they all do restrict rows. All right. And the syntax is correct, whether data is returned or not. So the correct answer is all of the above. All right, number 4. So what's wrong with that query? I know you all love these. So what is wrong with that query? And this is probably the biggest error that you'll see in using subqueries. So your choice is the subquery returns more than one row. The subquery references the wrong table in the where clause. Single rows contain multiple values and a logic operator is used. Nothing, it will run without problem. All right, so since we can run this query in our SQL developer, I would suggest whenever you have a question, go ahead and do that rather than trying to determine, oops, I need to copy the whole query. So select, oops. Here's our query. And if we run it, and you can't read it, but it says single row subquery returns more than one row. So basically, it's only because we're using a single row. If you remember, we're using a single row query operator here, where salary equal. So that's going to turn more. If you're turning more than one row, then it's not a single row query. So yes, A would be the correct answer there because of the comparison operator of the equal sign. Okay. All right, write a query to return all those employees who have a salary greater than Lorenz. This one, actually, everyone did pretty well on. Pretty straightforward. And this was an open, basically you had to produce the query. So select whatever you want to use for your column from employees where salary is greater than, and then your first subquery and department ID. Your second subquery with Lorenz and Abel in your as your last name. And remember, those are last name. I did have one person on one of the queries use first name. Oh, it was number 6. Please write a query that displays the name of Taylor's department and use a subquery. So basically what I wanted you to do there, select department name from departments where department ID. So the query should look like this. Department ID is equal to select department ID from employees where last name is Taylor, and we know it's sales. And I gave you the answer there. And finally, and this one, I thought there would be more of a problem. You all did very well with that, the final one with Ernst, using the group by and having. I think you guys are very good on these aggregate functions, so I'm not going to worry about that. So other than a couple where there's some syntax or some column naming or even some table names, and the conceptual tables, I am going to change that. I do want you to do more running some of these scenarios right on our little, although I'm prompting the Oracle Academy to give me an updated data employees database. So maybe the next group of students will get something that's a little bit more current. That's all right. So overall, it was not too bad for the quiz and the assignment for module 9. So thank you. So let's go on to module 10. This module is pretty important because now we're going to manipulate the data in the table, and hence data manipulation language, or DML. You'll hear that a lot. You need to differentiate between that and your predictive, or essentially your regular, we'll call it the core level SQL, the select statements and all that. But here we're actually going to possibly change data, add data to tables, and that's the premise behind this. All right. So the first thing that we're going to do, and I eliminate the ridiculous purpose statements, you'll hear less of those because they're a little bit elementary. But the objectives, and I do mention them after the objectives. So I'm contradicting myself. But anyway, we'll buzz through them. So explain the importance of being able to alter data in a database. Obviously, we have to do more than just selecting, and construct and execute an insert statement, which basically we're inserting records. Now we're actually adding to our data. And we need to think about unique values and null values and date values. All of that has to be considered. And then construct and execute insert statements that copy rows from one table to another using a subquery. And that can be useful, especially if you have data movement because of merging businesses or whatever. All right. So up to now, we've learned how to access data. And to summarize this, DML is pretty important because all of that that data that you see moving around is going through some type of language that's deleting or inserting or updating. So that's primarily the purpose here. So think how many times school students, yeah, and you actually, believe it or not, if you go into the SIS of CGCC, that's a huge database that's being manipulated by the front end. It's a web base and it's running some automation, but at the core, it's just a huge database with names and phone numbers and everything. So yes, and it is truly a relational database. So the first DML statement we're going to learn is the insert statement. The insert statement is used to add new records, new rows. It is still basically the way that things are. There's no magic in how data is added to a table. It's, if you look at the core of all embedded programming automated systems, somewhere deep in the core is an insert statement when there's data being added to the table, a relational table. All right, so how can we insert data below? And basically, I created a copy of the departments table because we wanted to add a new department. And you don't necessarily have to make copies of tables. I will allude to that a lot. It is okay to modify these tables in your instance. When we started this program, we had shared instances, and basically you would modify your version of it and you modify everyone's. But the technology has evolved, so whatever you do to your instance, you're doing it. And I'm going to go over a way as to if you make a mistake, which I'll tell you my little story about updating. So the syntax below, or the syntax for an insert, is essentially this: insert into, those two keywords, and then your table name, and then your columns, and then your values that you're inserting. And notice that whenever you run a insert query successfully, you either get an error or you get however many rows you're inserting as an indicator in the output box. So you see here, we're inserting a new department, human resources, etc., the manager ID, the department ID, etc., and the location ID. Yay, one row inserted successfully. All right. So another way to insert, which you'll see mostly, because usually when you're inserting any type of record or data into a table, you don't necessarily need to know all of the columns. Well, you need to know what's in the table, but you can implicitly add data without listing the columns. And this is probably more common, but it's also a good way for you to receive errors if you don't satisfy all the constraints or requirements for the columns. So you can run that same query, that insert query with the new departments this way. As long as you satisfy if there's any not null columns in here, they have to have data. And we'll talk about this a little bit more. But obviously, this is a simpler way to look at that, but it's assuming you are going to satisfy all the columns that require not null data. That is important. So that will do the same thing. We just excluded insert into departments. We would have the column listed here and then the values there. So the keywords that you need to be aware of: insert into and values. And your values always need to be enclosed in parentheses, and then strings in single quotes, and then numbers, and well, strings and dates in single quotes, numbers, no quotes. All right. Okay, let me, all right, I need to see who's here and who's not here. Is Jose here? I don't see him. All right, let's continue. So the best thing you can do, and this is where that describe statement or function, whatever you want to call it, comes in handy, because all of the columns that are indicated by not null, if you run an implicit, insert, you need to make sure there's always data to satisfy the not null. Now, if you run this particular department's insert and just exclude manager ID, then those columns will be the system would insert a null into those values. Not necessarily a good thing, but you can, if you have a large insert, and we'll talk about that a little bit later too, but before you start manipulating any of the data, I'd always describe the table. That's a safe way to make sure you're satisfying or not running into any of the constraints. All right, so just to review some of this as far as a summary, remember that describe gives you an overview, a high level, not a detail. If you want detail, basically I would just use the Explorer or the nice little GUI in SQL Developer to extract some of the information. You can run a query, but the describe gives you a quick overview. And basically it's the title of the column, if it's null or not null, and then its data type. And those are always very important. It used to be a little bit more detailed than this, but these, like you can pull out primary key and foreign key and all that, but usually it's pretty straightforward. And generally those type of constraints you are aware of, or you're just looking to have more problems with your database. All right. I don't think we need to go into some of the details of describe. I mean, we've gone through that enough. You can insert rows with null values. Basically, it has to be a column that's listed as a, basically, if it's not null, then you can't insert nulls. If it is null, then you obviously need actual data. So if you look at this query, if we look at the employee table, we're inserting employee ID, first name, last name, phone number, hire date, job ID, and salary. And I did have, if you take a look at the employee tables, there's more columns than those, right? You all know that, right? So, but if we describe that, that employees tables, you know that these are the only, well, these are mostly the only ones that are not null. So let me do that first, just to show you. Again, you just saw it, but I'm going to bring it up again so you can see what I'm referring to. So if you describe the employees table, you see that the columns that are absolutely required in any type of insert is employee ID, last name, email, hire date, and job ID. And you get that from, but if you do a select star, you see that there's more columns: salary, commission percentage, manager ID, department ID. And yes, and you see that in our little database here, if you don't include those in a query like this, it just fills it with nulls. But I'm getting an error here because there's one of these columns I'm not satisfying. I don't remember which. So which column is producing this? Well, it actually shows you here. Basically, we're not providing an email. And if you look at my little describe again, the email is one of the not null columns, right? So you'll get an error message like this, just saying, do not run an insert without satisfying all the not nulls. All right. So the lesson here is be very careful. Do your describe first. Let's see. And then when you do insert a record like this, and usually there's some type of batch job or something that will just dump data following the same criteria, and then you as a data analyst or a database administrator going back, adding information or using a form or whatever, but that's usually the case. All right, so you can insert special values like user or sysdate. That's two of the basic. Remember, sysdate is just a date, the current system date. So, and essentially when you get hired or when you become a student, usually there's a default to a system date. So no one's not making a mistake with the date. So yes, that's another way to kind of, add information without actually having to type it or refer to it. Remember, the default format has changed here recently. It used to be a little bit different, but it is day, month, which is your 3-letter month. and year. Remember, if you want to change that format as far as the type, as far as what you're reading in the table itself, and it is not recommended, to let you know, and many of your DBAs will tell you do not change the date format because essentially it's just a number. This is just what you see in the front end of your table. It's always still an exact date, but the default format in the table is always this format. Now, sometimes you may have to create a more readable, if you want to think of it that way, because generally in the US or in the West, this is kind of accepted globally, the day, month, year. We want month, day, year, and it's always, that's ingrained in how we see the date. All right. So here's a few examples, and you can review this if you wanted to change the format of the date. And sometimes you'll need to do this. Generally, you don't want to do it, or you don't want to perform any type of task like this when you're inserting dates, because you can always convert it when it's selected, right? You all know that, right? You do a tochar, change the format. All the dates that I've always used as far as the tables was always the default format. If there's any reason to change that, then you change it on the other side of the whole equation. All right. And these are just examples of taking the date and possibly changing it. Once again, I would not do this, and you can change it to date, always second, minute, second, hour, etc. There may be a time if you're working for the government or whatever, they may want to have that type of, recorded date. Usually not. It's usually not any question about the format unless you're using some type of output, just to let you know. But you can change it on the insert. I've never done anything like this during my DBA days because there's never a need to make that more of a granular kind of date reading, but it is possible. So the lesson there is, remember, if you have a date, as long as you know the system can read it as a date, it will store it in the table with the default date format, the day, month, year. And yes, it is 2-digit year now, until we get to the next millennium, which we're all not going to be around. I don't want to be around when it turns. Actually, no, it says 2100. Yeah, I'll be long gone. Maybe some of you will be around, but not me. All right. So you can use a subquery to copy rows. And in this scenario, each insert statement, well, we have seen each insert statement we've seen so far has only one row. Suppose you want to copy a lot of rows, 100 rows, 1,000 rows, 1,000,000 rows. Yes, you can use a subquery to do that. And basically, it's kind of like the correlated, but it's not really any different. So in this example, we're using a new table called sales reps. We want to populate it with basically populate it with employees that are in the sales department, right? So you see here, insert into sales rep. This is a new table, ID, name, salary. So these are columns that have been created in this new table. And then we're just selecting it. And notice the format of this. It's a little bit different, but it is a subquery. So basically, we're selecting employee ID, last name, salary, commission percentage for employees, where job ID, like basically. So if any type of rep will be added to this table. And the reason why I'm showing you this in this level of detail, yes, the select or the subquery select is only different in your insert into. So be aware of that. All right. Does that make sense, everyone? We're all still with me? I haven't put anyone to sleep yet, have I? Oh, good. All right. All right. So there's some key factors, and it's common sense. Make sure the number of columns match with the number of columns that you're inserting into. If there's any constraints, i.e., not null, you need to make sure that's all satisfied. Generally, if you want to use a subquery, you want all the constraints to be satisfied on the main query. So once again, just highlighting this. And let's say we want to, and here's another way to make it simpler. Let's say we want to copy all of the employees from the employees table to our new sales reps table. So you can do that. And with a statement like this, insert into sales rep, and then just select star. It will copy not just all the employees, but all the columns without having to actually create it. Yes, this is a good way to make a copy of your table if you want to investigate that. I think you get a chance to do that. You don't necessarily have to make copies of your tables because you can manipulate your tables all you want, and you can do a thing. You can do a revert back with your, and I'm going to show you how to do that if you want to essentially revert back without running that or long script. But anyway, this is a nice simple way to copy data from one table, any amount of the table, any amount of the data to a new table. All right. All right. So that's our insert. Insert. Hopefully you got a feeling for that. It's a way to add new data to your table, and this is one of the data manipulation language. Please make a note of that DML. You'll hear that, and now you know what it means. And then insert, and then values. Start in the whole DML down the DML path. All right. So of course, if you understand how to insert data, well, you need to know how to update and delete data. All right. So our objectives, I'm going to teach you how to update, how to delete. Update and delete, there's some important requirements to that. And if you're not following, if you're not very careful, and even some of us that are professionals sometimes forget about some of the requirements. I'm also going to explain how foreign key and primary key, these constraints will help you to not cause any issues, especially when you're updating and deleting, especially deleting. And then there's a couple of clauses that for update, basically you can lock things, and we'll talk about that when we get to that particular part of this section. All right, so some of our great purposes. Wouldn't it be wonderful if you don't have to do anything after things have changed? Of course, there's always changes. There's always changes in data. Data is constantly moving. Yes, your bed would stay made. Your clothes would stay clean. Yeah, we all know that that's not true, and you will always get a passing grade. Yeah, unfortunately, in databases, as in life, there's nothing permanent except change. What a cliched statement. I know you're all chuckling, and let's not go there. But as a database administrator, I can tell you when I started, of course, it was far too many years ago, I would work 12 hours a day just making changes, changing usernames and passwords, updating records, on and on and on and on. Because I worked for a university. I was their what did they call me? A DBA. I had all kinds of titles, but one of the main things is I maintained that it was a PeopleSoft database back then, although that's still pretty popular. Anyway, I digress. But back then it was a lot of fun, always doing something. And before I get into update, I'll tell you my story. This is about maybe 30 years ago. I was a pretty large university, so I was in charge of student, faculty, staff, and any tertiary employees. All that data came through my little cube because I was the DBA. I was a primary DBA. I had a couple of graduate students that work with me, but I didn't let them touch the data. I run all the queries myself. But anyway, there was back then a lot of the forms weren't that accurate, so we didn't have a lot of front end. A lot of it was truly automating data coming from spreadsheets, etc. And I would have a bunch of subroutines and all that. You'll learn about that I would just run. So it was a lot of, I had pretty good work security or job security. So there was one instance where there's a particular department or group of faculty or whomever, I don't remember, that were getting a pretty substantial raise because of their work on a grant or whatever. And so I was tasked to run the query to give these particular individuals about, I would say about 20 individuals, pretty good raise. It was like a 20% raise or something like that. And I forgot my where clause, so you can guess what happened. All the faculty members in the university got a pretty big raise, and they're going to take it out of my salary, but I tried to roll back and said, no, don't do that. So anyway, so don't forget that where clause, and we're going to talk about that a little more. All right, the update statement. The update is used to, you got it, update data that needs to be updated. So the syntax is update your table, set your column equal to the new data, and then a criteria. So I will warn you, and I'll say this 100 times over the next time that we're together, make sure your where clause is there, so you're not changing all of the data. So you see here, update employee set phone number equal to, this is a new value, where employee ID based on a criteria. Very, very important. Make sure, and then there's a way in Oracle and most database systems that you can do a quick rollback, but yeah, we're safe that way. In my old days, it was always running the backup, which was kind of ridiculous.
So what happens if you don't have the where clause in there? Does it change like the whole column of phone numbers?
Yes, all the data. Every single person will have the same number, and that's probably not right, correct? So, yeah, and we're gonna run an example of that in our little experiment today. So, all right, so you can change several columns. Just you separate each of the columns you want to change with a comma. So update employee set phone number equal to last name equal to Jones. So you see here the result. Maybe these two people are related, et cetera, et cetera. So yes, it's very useful, but it's very powerful. So you do need to be very careful. All right. So as I said, take care when updating columns, and we'll add delete onto that later. If the where clause is admitted, as Evan asked, every row in that table will be updated. And yes, that may not be intended. So don't do that. So don't do something like this. Update and then employee set phone number equal to this and last name equal to that. And so that's probably not what you want to see. All of our employees are now related. It's a pretty big family company. You're all Joneses. Oops. So we changed everyone's name to Jones. Whoops. All right. But one thing I want to remind you of, the good thing about Oracle and most other database systems, if you make a mistake like this, you can run what's called a rollback. And basically all you do is just, as long as you haven't performed an explicit commit, and then you have to go through other iterations, but you simply just run a rollback and it'll roll all the data back to where it was before you ran that command. So please remember that. If you make a mistake like this, and I actually ran this in my little, all the employees were now named Jones, but I didn't think that was a bad thing, but oh well. All right, so quick lesson on the rollback, and it's just rollback and you run. All right. All right, so updating continue. We can use the results of a single roll. Yeah, so subqueries, yes, you can use subqueries in any of the DML statements. Just once again, be very careful what you're updating. That's kind of the whole, and hopefully you'll get into the habit of practicing some of this to make sure your data is not manipulated in a way that you do not want it to be. All right. All right. Yes, you can update several columns at the same time. You see here, I'm updating 2 columns with a subquery. Yeah, subqueries are very useful. It's the one thing that I use a lot, and in our very simple database. And as I illustrated before, there's always something changes, some phone number, someone's getting married or getting a divorce, or changing their names, so you have to be aware of all that. All right. Remember those correlated subqueries way back? You're probably like, I don't want to. Please don't make me. But yes, you can use those in an update. And basically, the whole purpose of a correlated subquery is you're wanting to update basically information multiple times, in multiple ways based on a single query. So it'll do like essentially one at a time to update the information. Let's say we have a whole department that we're changing everyone's in a specific job title to a different title, and that's not this example, but you can. That's all a correlated. That's the difference between a correlated subquery and running a regular, just essentially a single row subquery. Just remember that it's correlated, meaning it just goes through each role, each record to satisfy a requirement and makes that update. Another powerful way, and hopefully you can run some of the practices. All right, update, once again, is used just to update data in your table. Delete, and yes, be very careful with delete. One of my cardinal rules is never run a delete without a where clause, because you don't want to delete all the records in your table, right? So do not, and of course, thank goodness, when you delete, you're not actually deleting it from the database system, because you can roll back even with the delete and bring your data back. And you're like, phew, thank goodness. But delete is just that. The syntax is delete from table where, and please, there should be some type of filtering or requirement. As a matter of fact, whenever I run this SQL class in person, I will test some of the individuals. I'll write on the board, run this query, and I will eliminate the where clause, and everyone's like, we can't run that query. And anyone that runs it, I mean, they get an automatic 0. So don't run a delete without a where clause. So you can use subqueries in a delete statement. But the one thing that will save you on delete are the constraints. Remember the primary key, foreign key. If there's certain data that's tied to certain data, you can't just arbitrarily delete it. So the one thing about that part of it, even in spite of the rollback, you see here, we're trying to delete from employees where department ID, basically we're wanting to delete all the employees in the shipping department, but we can't just do that. We need to make sure that there's no employees in that department or delete them one at a time, because we're violating an integrity constraint. And that's basically the connection between the employees and the department table. Even though we are attempting to run a delete based on the select from the departments table. So be very careful with that. The lesson here is that, yes, the constraints will stop you. And if you need to, either you're going to disable the constraint, which I don't recommend you ever do, or ensure that everything is in place before you run any type of delete. Right, here's another example of a subquery delete. And basically we're deleting, delete from our copy where the manager, so we're deleting everyone that has more than two, every manager that has more than 2 employees, we're deleting them. So maybe there's some restructure. And so if you ran that, basically it takes all the employees. So if it, all right. So the example, deletes all rows of all employees who work for a manager that manages less than 2 employees. All right. So maybe we're going to make them more, we'll put more managers on the employees management, or more employees under the manager's guidance, whatever. All right, so let me talk a little bit about integrity constraints. And this is one of the things that you really need to be aware of on the whole DML or manipulation of data. The constraints were put in place just to set the rules so that you don't arbitrarily do something that you may not be aware of. For example, the not null constraint is very, very important. For example, insert or update, and you're not satisfying that not null constraint, you will get an error. And usually these errors are easy to interpret, as in this one. Basically, it's saying that that particular column, last name, cannot be null. And we're trying to update this wholesale with a subquery, and it is creating a condition where there's a null. So that is the whole idea of an integrity constraint. All right. Let's see. What did I want to do with this? So this is the employees. So just an illustration of the connection. Remember, we have departments, and there's a primary key, foreign key connection between the employees table and the department table on purpose. So if you ever wanted to delete a department, you would have to ensure that constraint, and it is an integrity constraint, has been either broken or removed or disabled. So that was all right. So with that being said, this is your check for understanding. Which of these queries will return an error, and why? Based on what your knowledge is of what those constraints are in our database. How about one? All that we're doing in one is changing an employee's department. Can we do that?
Yes.
Daniel says yes. All right. Nope, this will return an error because department ID does not exist. So if you take a look at the departments in our little table, it's 10, 20, 30, etc. So yes, you can do that, but okay, it's kind of a trick question. I apologize for that. How about two? Yeah, you see the whole query.
I would think 2 does not, because it says department underscore is instead of department underscore ID.
Oh, that's a typo for my, ignore the typo and imagine that says ID. That's pretty bad, I'm sorry.
Then it will.
Yeah.
So no. So delete from departments where so you're deleting the whole department. So that there's probably employees tied to that department, so that is a no, because there's employees. And what about finally, and I didn't make a typo, what about number 3? So basically you're updating employees, set department ID equal to 10, where department, so basically you're shifting, and we know that 10 and 20 exists. So, but we're shifting the employees from 20 to 10. Yes or no? You're all hesitating now, right? It's not a trick question. That one will pass because basically we can do that because you're not removing any employees. We're just updating. You're allowed to do something like that. So, but the other two, no, they will give you an error. Integrity constraint error. Go ahead, Daniel.
Yeah, for the second one, is it because department ID exists in the employee table and that's why it won't?
But primarily it's because they're still employees. We're trying to delete the department, right? So there's employees still in that department 10. So we would have to do 3 first and then, or actually not 3, but we would have to delete, change all the employees from department 10 to whatever, and then we can delete the department.
Got it. Okay. Thank you.
So if I'm thinking of it correctly, so it's because there's information containing it, I guess, on another table. It's going to create that an error.
Right. So if you look at the employees table, let's bring that up right quick. If you look at the employees table, we have a department ID in here, right?
Mm-hmm.
Right here. So that says all of these employees, except for this one, Grant, is in these departments. So as long as you have employees in those departments, you can't delete it. You can't run a delete. You can't run a query like that, delete from departments. Because it's basically, you're deleting the department, but you have a relationship between the employees and departments. You would have to remove the employees first. You'd think, yes, I can delete the departments and employees, but generally that's where the constraint is, because that is actually a foreign key of the primary key that's departments on the employees table. So,
Yeah, that makes sense. Yeah.
all right. Moving ahead. And we just talked about that. Yeah, it's all about the connection between the two tables. All right, so there's a clause that you can use basically to lock data so that someone cannot change it while you're selecting it. Or you can lock it so you can update it so someone can then select it, either way. So the for update, so when a select statement is issued against a data table, no locks are issued. That's basically a system. So most of the time, and these large databases and the speed of the databases, there may be simultaneous queries being run in the modern database scenario. That does exist. So this is very rudimentary. You probably won't see this in the real world, but there's a clause called labeled for update. So you use this as soon as you run a for update, and as long as a commit or a rollback hasn't been submitted, then basically you're locking whatever the command is until you either run a commit or do a rollback. So if you use for update in a select statement with the multiple tables in it, all the rows from all tables will be locked. So basically, this query here, we're running this until there's either another query or a commit submitted by this user. And once again, we're not in a multi-user scenario, so it's hard to illustrate this. But basically, you're locking this table or these tables. You're locking employees and departments. And you're doing whatever you need to do with it until you run a commit. Does that make sense? And it's usually not a big deal. If this was our small company, and you were probably the only data analyst or database administrator, you're probably not going to lock it down, especially with the resources in these new systems. You can probably run a query and not have any collisions or anything like that. But in the old days, yes, this was very important because we would produce. It's the opportunity to produce dirty data and things would be all mixed up. But we've gotten over all that, thank goodness. So it talks about locking the rows and basically it stays that way until you either issue. And remember, a commit basically tells the system that we're now committed and we're opening up basically anything that was locked. And a rollback basically is the opposite. We're removing anything that we did and we're rolling it back to whatever it was and unlocking all the locks. So will you see a lot of that? Possibly no. But that's another aspect of SQL that you should be aware of. All right, so further terminology on the DML side: delete, integrity constraints, update, then the correlated subquery delete, the correlated subquery update, and then the for update of select. All right, moving on to section 3, the default values, the merge, and the multi-table inserts. So basically our objectives: understand when to specify the default values, and we'll get into that. The merge statement, DML statements using, well, we just did that. And then multi-table inserts is probably the biggest thing here. So up to now, we've been updating single insert statements, and we're going to multi-table inserts. Very useful. It's been relatively easy when adding records one at a time. What if your company is very large? And most companies are, as far as data. They're using a data warehouse, which is a large amount of data, several tera or even petabytes of data now, several million tables. Just imagine that. So in this case, data is probably coming in from multiple sources. Yeah, And this is kind of the future, and it's still managing data. And in many instances, it's not like our little simple examples. There's probably several million queries running simultaneous. So, wrap your head around that. But anyway, let's break it down. We're just going to talk about kind of the context of what we're learning. So how do you determine what has been newly inserted or what has been? So we're going to kind of diffuse the large level picture and just look at, kind of simplifying some of these aspects so that you can learn and scale it up to the larger scenarios. All right. So let's first talk about default values. Default values are primarily used when you create a table. We're going to get into creation of the table structure in the next week when we talk about DDL. But we're going to talk about that a little bit. You can use some of the functions, the system functions like sysdate and users to create default values, and that's usually the case, especially in multi-user environment, et cetera, et cetera. All right, so the first place that you'll see users, and we're not going to go into this, we'll go more into this when we get into DDL, is when you create a table. When you create a table, you can actually set a default value. In this case, we're creating this My Employees table, and we're setting a default value of the sysdate for the hire date, which makes sense. So whenever that information is inputted to this table, the default value of your entry date will be the system date. Very, very easy. And that's kind of the default of the defaults. And so these are called explicit defaults because you're setting the values of that particular column. And you can use explicit defaults when you're doing insert. As you see this example, we're inserting an employee into our new My Employees table. And you notice that we use in our values, we use default. So because we set the default back here as a sysdate, and this is where this is useful. So basically, when we insert values, we just need the first and last name, and it'll default to the sysdate. And you can try this on the employees table now, and hopefully when you run some of your queries, you'll see that you can run a query like this, insert first name, last name. I inserted my name, and it actually defaulted to the sysdate that I used last year. Very useful. Cuts down, makes it more efficient, et cetera, et cetera. Remember, those are called explicit defaults. And I just went over that. So even if you want to use an update, that's an insert. You can also use explicit defaults in an update scenario. Remember, if you use the term default and it's set in the table as a default, it's the same as substituting sysdate for this particular scenario. All right. Does that make sense before we move on to merge? Pretty straightforward. If you get into a lot of data manipulation, default values, especially dates, makes huge sense. All right. Let's talk about the merge statement, a merge command. So it accomplishes two tasks, and I use this quite a bit. Merge will insert and update simultaneously. And you're like, oh, how does that work? Basically, as I explain it, when a record needs to be inserted, it will insert a value. If a value in that record needs to be updated, it will do that as well, all in this merge statement. And you're probably thinking, well, that's kind of like magic. Well, not really. If you think about the programming behind SQL, a statement like this makes sense because you're not always going to need to insert or update. If you can do both, which was the whole idea when the merge statement was created many years ago. So before I get into an actual example, so basically the way it works, and I'll go over the syntax, one row at a time is read from the source table and compared to the rows. We have a destination table using matching condition, hence the merge. So you're merging, possibly updating and inserting information from one table to another. If the matching row exists, the source row is used to update one or more columns in the matching or destination row. If the matching row does not exist, then an insert. So it's going to do an insert and update simultaneously. And the syntax, you have a destination table and a source table. So essentially, and it's actually a little bit more sophisticated than this, but we're not going to go that route. Just think of this, and when you see the example, it'll make more sense. So merge onto, and you have a destination table using your source table on matching, and then you have a condition when matched then, so the whole when then. And those of you that are programming languages, this could kind of make some sense. So when it's matched, then you do this. When you update, when it doesn't match, then you insert. So that's all it says, and you give the values for the insert. So you notice the update is always set, the insert is always values. You're like, uh-oh, this is getting pretty complicated. It's a head scratcher. Not that bad. So what I'd like for us all to do, everyone, open up your SQL developer. We're going to run a merge, a merge example together. And it's pretty straightforward. So what I want you to do is create this query, create table, copy imp. It's a copy of employees table. So basically we're going to copy all the employees that are in department ID, then department IDs that are greater than 100 to our copy imp table. So run this query, create table, and I'm going to run it with you. Create table. Copy. And you can name it whatever you want. Copy imp, copy employee. As, use the keyword as, and then in the subquery, select star from employees where department is greater than 100. Department ID, sorry. All right, go ahead and run that query. Don't panic, we're going to, you can always roll back. And it should say, you should see an indication, table copy imp created. Did everyone get that? And if you want to be sure that that table exists, go ahead and do a select star from. Make sure you have data. All right. Are we all good with the data? It should be, well, at least 2 employees, Higgins and Geitz. All right. Right? Got all that data in there? Woo. Good job. Right? All right. So what we want to do, go ahead and update your copy table, set last name equal to Cotton for 205. For Higgins, we're going to change Higgins to change her last name to Cotton. All right. Nice little practice. Update. Y'all probably type faster than me, right? And make sure you do employee ID 205 and not the whole, both employees. That's not good. All right, are we there? All good? Shelley is now Shelley Cotton, right? Make sure you do your select star and Shelley Cotton. All good? All right. Whoops. All right. Now we're going to run this. Merge into copy imp and give it an alias using employees on employee ID equal employee ID, right? When matched, then update, set last name equal to last name, department ID equal to department ID. When not matched, then all of these columns we're going to insert. So go ahead and run that. Of course, you have to type it in. I have to as well. And it's merged into destination table, source table, and so on. Let's see how you all follow instructions. See how the merge works. And this way I can keep you awake. Oh, and make sure you spell everything correct when matched. Yeah, there's a reason why we changed Shelley's last name, and you'll see once we run it. All right, who's run this already? Who's the fastest typer in the room? I know it's a lot of typing. But you get a gist of just how this works. First name. Yeah, there's too many columns in that table, right? But if you don't put all the columns, you'll run into problems with the merge. And if you don't type them right.
What?
All right, who's got this to run?
Sorry, I'm not a fast typer. Stop.
Well, I got an error on mine. When matched, then update. When not matched, then insert values. Oh. Oh. Yeah, that's a typo. For me. There we go. You should get 20 rows merged. Right? And when you select your copy of employees, you should have your regular employees back, including Shelley. Everyone, so once you run this, how many of you finish? So I just want to show you when you run this. Now, when you do a select star, you see we have our 20 employees, and instead of Shelley Cotton, she's now Shelley Higgins again. So why is that? Who can tell me why? What happened to Shelley Cotton with this merge statement? When match, then update. When not match, then insert. So it matched Shelley because of employee ID. So then it updated her back to Higgins. Does everyone see that? Because it didn't match. So now she's back to Higgins. And then everyone else was just inserted. So that was the update, and then everyone else was inserted. Right? Does that make sense? That's a merge into. So if you didn't finish, that's all right. I just wanted to show you the results there. All right. All right, now you can drop that table if you like, or you can keep it. That's up to you. But the syntax is just drop table, copy imp. Because it's just a copy of your employees table. That's strictly up to you. All right. All right. Let me go into multi-table inserts. Basically, you have to be very careful, and usually this is high level of data. I talk about things like making sure, as far as the number of rows and customers, etc. These are the things that you want to be aware of. Multi-table can be conditional or unconditional. And Oracle will protect you in many ways. We're not going to run an example because our database just doesn't really support it that well. Usually when you have a data warehouse scenario, you're running a multi-table insert. And it's just an insert that's ran in many ways. I think I am going to give you an example here. The syntax for a multi-table insert is insert all into, and then your clause values, your clause subquery. You can see here, insert all into my employees, a new table, values, column names that we're defining, and there has to be a correlation so we're going from my employees into copy of my employees. And basically it will insert all the data that's necessary based on that, whatever you're restricting. The reason why I'm buzzing through this, normally if you're copying data in this way, you're doing a wholesale copy of the table and then you're manipulating it from there, as opposed to using many subqueries. It's probably very confusing for this. Let's see. So I wanted to show you this example. Insert all, that's the syntax, into, and that's your columns for your new table, your copy table, values. And see, this is your values. And then into these columns, and so on. And you can do that just as long as you ensure that basically all the data points are needed. And generally you run this scenario many times, but you're inserting the same values into copies of, if you're copying the employees table, for example. Here's another conditional one, and this is actually one that a student used to highlight call format from cell phones, if it's talk or text or picture. And if you read through this, and I'll post this, you see that it's basically a when call format is this. If it's in that, then you're inserting it into all calls. If it's this, you're inserting into police recorded calls. When it's call duration, when it's less than 50, it's short calls. When it's greater than 50, it's long calls, etc. So this is a very good example, a kind of sophisticated one where you're just setting conditions where you're inserting values from probably one table into several tables. Will you use something like this on the SQL level? Probably not. This was just an example that a student created from his Oracle database to track the types of calls. All right. So our terminology for this last section: default, merge into, multi-table insert, all first else, and then when then. And this is the multi-table. We didn't go through that, and you'll see examples of that once you get into the practice and the quiz, etc. Okay. All right, so I know we're going a little bit long. Let me get into what we can expect for Module 10. All right, so there's an extra credit opportunity quiz, and basically it's open the remainder of the semester. And basically you can, if you think you need some extra credit points, and you don't get it, it's not something that goes against you if you don't go in there. It's extra credit. All right. So you can go in there. It's a quiz. It has several questions. You can complete as many or as little as you want. You get benefit for what you complete. All right. Let's see. Let me open that up briefly. So there's 23 questions, and it's just scenario questions. So once again, it's not required. It's only for extra credit. And it's just like a regular quiz. So you don't get deducted for missing scenarios. If you go through all of the questions, you get credit for all your correct answers. Nah, that's a long way to get around to that. So, all right, so that's the extra credit. That's this week. And yes, remember, this is open the remainder of the semester in Module 10. All right, there's a database command. We are going to get into DDL next week. That's basically affecting the attributes, tables, etc. And I want to introduce you to that right away. We went through the DML. Select is actually a part of the DML language on the SQL, in case you want to know that. And then DCL, we won't do a lot of that because we can't really change the uses and privileges, but you need to know that. And then the TCL, or the commit and save point and rollback. That's the highest level of the system. So I wanted to introduce, these are actually on the finals, so please be aware of the different, we call them languages of the SQL, or categories of languages of the SQL. So that's why that's there. And then your practice queries, several from all the sections, everything that you need to know, primarily, and don't be afraid to manipulate your instances. You can always roll back or just keep things the same. There's a lot of copying tables and etc. Do as many of these as you need to understand the whole DML. I do recommend insert, the update, and the delete. And yes, once again, be very careful with the delete. Deletes without where clauses are not allowed. Yeah, if you're caught, then that's automatic 0 for the whole class. All right. Our requisite videos for more information. It's interesting. Some of these, well, most of these videos I tried to pull in recent, but all of what you're doing now is really not new, I guess is what I'm trying to say. And it's still applicable. It's interesting how that is, or why that is. And then your practice and solutions as normal. And the 3 sections of all the nice, and you probably notice a lot of these are in the quiz and in the assignment. So please go through these, practice. And then the assignment itself, 6 questions. You're all still doing pretty good there, so don't feel. And I like to do something different this week. If you want to divulge me a little bit, I like for us all to go through the quiz together. And yes, I'm going to. I changed it a little bit, and I know that Matt has already done this, but I put this in the form of a Kahoot, so we're all gonna experience the quiz, and basically, there's some rewards to the Kahoot as well, but this is essentially the quiz. So let's do this. I know it's getting a little late, but this will be fun. I guarantee you. So here we go. So everyone, please join. There's only the 8 questions. And wait, I think we did Kahoot once before, but this is the quiz. This will count for the quiz. And I'll tell you, the 3 individuals on the podium will get exempt from the assignment. You get credit for the assignment. And this is your score for the quiz, unless you want to actually redo the quiz if you do poorly. So, and it is the actual quiz that's in the attendance. So, and I think there's only 8 questions, so this should go pretty fast. And you can actually, research the quiz because I changed it to match the Kahoot. All right, are we all ready? 10 of us. All right, here we go. All right, and so read this query and let me know the results. What's the best answer for the results? Take your time. In a second. Yes, it's 70 will be added to the department ID. We all see that. 1700 was the last, and that's location ID. 100 was the manager ID, right? Not department ID, and public relations was the department name. So 70 is the correct answer. All right. Complete the following query to add a new customer to the F customers table. Insert into F customers values you can quickly go to SQL Developer. Oops, sorry. Oh, we have it open. We have customers table. Which of these are valid? Seconds. Well, you see, we have the, if you do the, well, let's just take a second to, I need to make sure, being fair here, if you describe the customers table, you see that it's ID, first name, last name, address, city, state, zip, phone number, right? And so ID, first name, last name here, address, but that's missing the phone number, the red. The blue has everything, and in the way that it should be in the parentheses, right? Yellow is missing the ID. The green doesn't have the single quotes. Does everyone see that?
Yes, I see that.
All right. So attention to detail is a big thing. All right.
Yeah.
All right, keep going. The merge function combines the what? Which two are used in the merge? Just went through that huge big example. There are two statements that occur when you run a merge. 10 seconds. Yes, that's the insert and the update. Yeah, not create, update, or alter update. All right. All right. Yeah. Here we go. Employee 174 was recently married. Her last name is now Rockefeller. Which SQL query will change the employee's database? So look at the queries. Which one will we use to change employee 174 last name to Rockefeller? Hey, most of you got that. Update, it's not an insert. So it's an update, and the syntax is not update into, so it's update employee, said last name equal to Rockefeller. Yeah, good job. Most everyone got that one. All right. What would be the result of the following statement? Delete from employees. What happens if you run that? 10 seconds. Good job. You all got it right. Give yourself a hand. Yes, all rows in employees tables will be deleted. Good job. All right, coming down the wire here. The job title of programmer will be changed to software engineer. Complete the update statement. Update jobs. Jobs is the table. What's the rest of the statement? Ten seconds, 5 seconds.
Oh my God.
Yep, so if
Wait,
you read that, set job title equal to software developer, where job title is equal to programmer. Green is set job title to programmer, where job title, so that's not going to change anything, right?
Technically, it would be none of them because the question says software engineer.
Oh, it's okay.
Yeah,
Technically, you're right,
that's
but-
where I was getting confused too.
But you guys, you guys saw what I was thinking and not what I typed.
Mhm.
So Daniel, you're right. So it's supposed to be software engineer, but that's all right. You got it. Most of you got it right anyway, despite my my typing error. So thanks. So even if you missed that, you get credit for that one. All right, couple more. This was multi-select. You need to add yourself as a new employee. Which columns are required other than the employee ID? Select all that apply. And submit. All right, so it's last name, email, hire date, and job ID. First name is not required. Or meaning that you can update it without adding your first name. And if you
Oh,
describe the employees table, you'll see that.
that's where I got it wrong though.
So
I had a first name.
not all of them. Oops. Let me just show you this. Yeah, so it's employee ID, last name, email, hire date, and job ID. Yep. All right. Okay, last one. You can do it. Delete from employees where department ID is equal to, select department ID from departments where department name is equal to sales. What happens with this query? Yes, all employees who work in the sales department will be deleted, right? Because our subquery returns the department ID for the sales department. So off they go. Does everyone see that?
Yeah.
All right. So that's the
Hmm.
quiz. So before I show the results, you do have the option of taking your score here, which I will convert to the 15 points, or go back and just complete the quiz as it is. But those on the podium will get into, well, you can take the option of like being exempt from the assignment and the quiz. That's strictly up to you. You just have to let me know. So the podium consists of Evan and Daniel and Maria. Good job. So the three of you, just send me a message if you want to not do the assignment, but you just did the quiz. The rest of you, you can go through the quiz. Well, basically, yeah, you can either take your score from the Kahoot here. I'll convert to the 15 for the quiz, or just go through the quiz. That makes sense?
Hmm.
All right.
So I just want to be 100% clear. If we're on the podium, we can ask to be exempt from either the quiz or the assignment, or is it both?
That is
I
correct.
want
You can actually be exempt from both.
Okay.
Only Maria, you, and Daniel. Right? Was it Daniel or is it who was on the podium? I forgot already.
Yeah, that was me.
Okay, thanks.
Mhm.
All right. Any other questions or comments?
No.
I will make sure I correct that one question. You all get credit for it, so it was a misstep on my part, so. But, all right. Well, that's it for this evening. If you don't have any more questions, we will meet again next week. All right?
Really quick, what's the best place to message you on?
Just on Canvas.
Okay.
Canvas message. That's fine.
Mhm.
All right?
All right.
Okay. Thank you all. Have a good evening.
Thank you. Good
Bye.
night.
Thank you. Have
Good
a good
night.
night.